Hi, I'm Bob Sabo. This is Air Density Online. We're going to demonstrate tuning for altitude on a blown alcohol engine. We're in the shop. This is a blown alcohol big block Chevy. It's currently set up for sea level. It's out of the car right now. It isn't necessary to be in the car to show you what we're going to do. The overdrive is currently set at about 1.14 or 14% overdrive. This is a sea level setup, and according to ProCalc, it's about a 3.8, 3.85 air to fuel ratio. Okay, this engine has a single row of hat nozzles and a main bypass. And we're going to show you that that's all set up on a baseline profile. I'm already logged into Air Density Online ProCalc. On the baseline profiles, this particular setup, this is an 871 blower and it's a sea level setup. We're going to examine this baseline. Okay, it's 14% overdrive. It's a 470 cubic inches per revolution on the blower. That's an 871 at 470. I pulled that up with the link that's associated with that entry. I have a 95% blower efficiency because it's got a few runs on it. For a new blower with brand new seals, it'd probably be about 97 or 98%. And that efficiency value is actually a D rating for seal wear. We got a 12.5 gallon a minute fuel pump. It's 8 cylinders. It's 1 nozzle per cylinder. And our baseline is currently 130 thousandths main bypass. There's no high speed in this baseline or pump loop. The target RPM is 5,000 RPM. That's our stall speed on our torque converter. The tuning RPM is 8,000 RPM because that's the rating for the fuel pump. There's no nitro. Our sea level air density is approximately 80 degrees Fahrenheit, 38% humidity, and about a 29.84 for the inches of mercury on an uncorrected barometer. This setup's got 49 thousandths nozzles, and that combination gives us a 3.86 to 1 air to fuel ratio. That's pretty good for a blown alcohol big block Chevy. For a 470 cubic inch blower size. Okay, we're going to examine now determining the setup because we're going to be going to a higher altitude track, and what we're going to do is compensate for the altitude by simply changing the blower overdrive, and we're going to use the calculator to figure out how much blower overdrive to keep the same fuel mixture. Okay, I'm going to Air Density Online. I'm going to hit US Tracks. And this is a drag strip, so I'm going to narrow my list down. And it's Tucson Dragway in Arizona. Yeah, the uncorrected barometer is 26.87. That would be typical for a 3,000 foot elevation. Okay, I'm in my air to fuel ratio calculator, and I've got to enter my weather to see what kind of overdrive we're going to need to do to change this. Okay, it's going to be typically an 80-degree day, about 30% humidity, but the barometer is going to be about 26.8. Okay, if I don't do anything to my sea level setup and run the engine the same way, my air to fuel ratio is 3.47. That is really rich, and the engine isn't going to run very well. So what I'm going to do is determine what it's going to take to get our air-to-fuel ratio back to 3.8, 3.85, which is our sea level setup. To do that, all I have to do is change the blower overdrive in classes where you have that freedom to change blower overdrive. This one is 14% over for our sea level setup. I'm just going to try 20% over. And that takes me to 3.66 air-to-fuel ratio, so it's still rich. What I'm going to do is increase the blower overdrive to 30%. And that takes me to 3.96 air-to-fuel ratio, so that's too much. So let's go to 25%. And that takes me to 3.84, which is right in the ballpark of our air-to-fuel ratio. So for this track, if I do nothing but change the blower overdrive on the engine from 14% over to 25% over, the engine will run the same. Okay, to determine the overdrive pulley change, we're going to start with a 65. That's the tooth count of our lower pulley. We've put that into a calculator and we've divided it by 1.25. That's our overdrive. That comes up with a 52. Mm-hmm. Okay, this is a 57 tooth pulley, which is for our sea level setup. And this is a 52 tooth pulley for our 3,000 foot altitude. And all we have to do is put this pulley in place of that one, readjust the belt tightness. We do not change anything in the fuel system, and the engine should run the same.